Today our topic is collisions between different bodies. We will discuss about different laws which will be followed in these collisions. Okay. First of all, if two bodies are moving along the one line before collision and after collision, the motion is only in one line, left side or right side, so that is head-on collision. And if the kinetic energy does not change, that collision is elastic collision. Elastic and head-on collision means after colliding they remain on the same line, that is head-on collision in one dimension. Elastic means no loss of energy, no loss of kinetic energy, no loss of kinetic energy. Clear? What will happen when they come in contact? Suppose करिए at that position they collide, they exert force on each other. These are internal forces for them. If I consider these two bodies as a system, these two are internal forces, no external force. More important thing, internal impulse here. So due to the internal impulse, momentum does not change. So in the collisions, when the external impulse is zero, linear momentum remains conserved. The first point is linear momentum remains conserved. If external impulse is zero, okay, linear momentum remains conserved. Second thing, in this case, for elastic collision, no loss of kinetic energy. Kinetic energy also conserved. Clear? These 2 points will be followed when we discuss the problems of collisions. Third very important point, that is Newton's experimental law. Newton's experimental law. What is this law? It is velocity of approach of the bodies. If I take here speed after collision, it is after collision situation, before collision it is during collision, suppose speed u1 and u2, let u1 is greater than u2. After collision speed becomes v1 and v2, clearly v2 will be greater than v1. During the collision, exchange of energies are taking place and situation in the under no loss of kinetic energy, finally kinetic energy of this plus this equal to kinetic energy of this plus this. Okay, momentum of these two initially equal to momentum of these two finally. Newton's experimental law is velocity of separation. किस रेट से इनका सेपरेशन बढ़ेगा? रिलेटिव वेलोसिटी, दैट इज v2 माइनस v1 डिवाइड बाई वेलोसिटी ऑफ अप्रोच. किस रेट से इनके बीच का गैप डिक्रीज कर रहा है? दैट इज u1 माइनस u2. It remains constant. It is Newton's experimental law, and that constant is denoted by E. It is constant for two bodies. If you take different body, different surface, different material, that constant will change. For two balls, it will remain constant. It does not depend upon the speeds. It depends on the nature of the material of the bodies. Its name is coefficient of restitution. Coefficient of restitution. Clear? So this will be very useful while solving the problems, because when you use this concept, quadratic equation will be formed. Quadratic equations बनेगी. इसको यूज करने से and from first and this one suppose करिए third, we will get two linear equations can be solved easily. And for this E की value depend करती है. For example, for elastic collision, E is 1 here. For elastic collision, E is 1. Okay? For inelastic collision, in case of inelastic collision, loss of kinetic energy. For them, E is greater than 0, less than 1. When E equal to 0, that collision is perfectly inelastic. Perfectly inelastic. E equal to 1, it is perfectly elastic collision or elastic collision. If E lies between 0 and 1, that will be inelastic collision. In case of perfectly inelastic, E will be 0. Inelastic collision, E lies between 0 and 1. For elastic collision, E is 1. Clear? And that is velocity of separation. Velocity of separation divided by velocity of approach. In case of two-dimension collision, it is head-on, means one-dimension collision. In case of two-dimension collision, for example, if I take these two bodies, suppose it is moving like this and that body is at rest. When they collide, during the collision, they exert force on each other like this. Motion is in this direction. So internal impulse is in different direction. It will change the momentum of the bodies. And after the collision, these bodies move in different directions. Suppose the body A, it is body B. It is body B. they move in different directions. In this case, momentum remains conserved along two directions. We will conserve it along x axis, along y axis. We will consider components of the momentum along x axis initially and finally. Similarly, along y axis initial momentum before the collision, after the collision. Along y axis momentum will be conserved, but to apply this equation in that collision, velocity of separation along the normal of the bodies. For example, we take two bodies like this, it is the normal. Velocity of separation, final velocity of second body, मान लीजिए second is the first body, component of second body along normal, component of the first body after the collision along the normal. If both are in same direction, then दोनों का difference आ जाएगा. If these are in moving opposite direction, velocity of separation add हो जाएगी, प्लस हो जाएंगी. तो velocity of approach before the collision, component of velocities along the normal consider करने पड़ेंगे इसमें, बस ये difference हो जाएगा. And we will apply Newton's experimental law, both head-on collisions and it is oblique collision when body move in different directions. It is oblique collision. Clear? Now we will discuss some questions based on these concepts. Let us start one problem. Suppose करें these are two bodies of equal mass. One is at rest. They collide. After the collision, they move with different speeds. The before collision, it is after the collision, head-on collision is there. It is given final kinetic energy is 3/4 of initial kinetic energy. So we have to find out E for these two balls, coefficient of restitution of these two balls. So conservation of linear momentum आप apply करें, m into v momentum of this body plus m into 0 that equal to m into v1 plus m into v2. So clearly v1 plus v2 equal to v. Clear? This relation we get with the help of conservation of linear momentum. Now let us apply Newton's law, Newton's experimental law. Velocity of separation is v2 minus v1 upon velocity of approach v minus 0, that is equal to E. So you can get v2 minus v1 equal to E into v. Second equation, from 1 and 2, if you add them, you will get v1 plus v2 equal to v, equation 1. On adding them, 2v2 equal to v, 1 plus e. So v2 equal to v into 1 plus e over 2. Similarly, on subtracting from 1 to 2, you will get 2v1 equal to 1 minus e. So v1 equal to v into 1 minus e by 2. So these are final velocities at the collision, but the condition is final kinetic energy 3/4 of the initial one. So final kinetic energy half m, masses are same, half m v1 square plus half m v2 square is 3 by 4 of half m v square. Clear? Now simplifying it, you will get v1 square plus v2 square equal to 3 by 4 v square. Put values of v1 and v2 here. You will get v square by 4 1 plus e square plus 1 minus e square. This equal to 3 by 4 into v square. So after simplifying it, you will get 2 times 1 plus e square is 3. So 2 plus 2e square is 3. 2e square is 1. E square is 1 by 2. It means e equal to 1 over root 2. So in this question we have applied conservation of linear momentum, Newton's experimental law, and in this way we have calculated coefficient of restitution. Okay. Let us start one more problem based on these concepts. मान लीजिए a ball strikes to the floor. Floor is smooth and fixed. It strikes with speed v. Mass मान लीजिए. Coefficient of restitution for the ball in the floor is E. After collision, मान लीजिए it strikes at angle theta. After the collision, we have to find out what is its velocity and at what angle it moves with the normal. मान लीजिए velocity v dash. Our purpose is to find v dash and to find theta dash. Clear? Coefficient of restitution is E. Now collision is clearly elastic, but one body remains at rest because ball is moving, floor, two bodies are there, ball and floor. Floor remains at rest, ball is moving. Okay. In this case, let us apply Newton's law, Newton's experimental law. जैसा मैंने आपको बताया था, we have to resolve velocities along the normal and perpendicular to it. Component of velocity along the normal is v cos theta before the collision. Along the tangent, along the normal v cos theta, along the tangent at the point of impact it is v sin theta. After the collision, along the normal velocity becomes v dash cos theta. This angle will be theta dash, v dash cos theta. Along the tangent it is v dash sin theta dash. Clear? Okay. During the impact, force is only acting along the normal. Impulse is normal to the floor. No impulse in tangentially. So no impulse in tangentially means velocity of the ball along the tangent will not change. Impulse is along the normal, so velocity will change along the normal. Okay. So let us apply Newton's experimental law. E equal to velocity of separation. Who is separating here? Ball is going up. Floor is at rest. Ball is going up. So velocity of separation is v dash cos theta dash minus velocity of the floor divided by velocity by approach. Who is approaching? Ball is approaching to the floor. So v cos theta minus again 0 because floor remains at rest. So clearly v dash cos theta dash equal to E into v into cos theta. Suppose it is equation 1, tangential component will not change. So v dash sin theta dash is v sin theta. Clear? So on squaring them, we can squaring and adding v dash square cos square theta dash plus sin square theta dash, this equal to v square common sin square theta plus e square cos square theta. It is 1. So clearly v dash is v root of sin square theta plus e square cos square theta. It is final velocity of the ball. You can find out theta dash dividing them. Second divided by first. You will get sin theta dash over cos theta dash equal to, it is clearly tan theta over e, this divided by this. So clearly tan theta dash is tan theta over e, or theta dash is tan inverse tan theta divided by e. It is angle of reflection of the ball after the collision. Okay, clear? समझ आया ना बच्चों? Good. Okay, let us take one more example based on these concepts. देखिए बच्चों, A block, B block, mass of A block is 2m, B का मास देखिए 4m, thickness ये जो बेस की लेंथ है that is 4d, height is 2d, floor is rough, coefficient of friction is mu, ब्लॉक्स के बीच में कोई फ्रिक्शन नहीं है, कोएफिशिएंट ऑफ फ्रिक्शन इज 0 है. क्लियर? नाउ वन बॉल स्ट्राइक्स along the line joining center of mass of the B block. बिल्कुल इसी लाइन पर टकराती है, इस पोजीशन पे. क्वेश्चन इज, इसकी जो कोलिजन होगी बॉल की कोलिजन वो इलास्टिक है, इलास्टिक कोलिजन. ये से कोलाइड करेगी, कोलाइड करके वापस आएगी. इट विल गेन सम वेलोसिटी, इट विल गो दिस साइड. क्योंकि ए और बी के बीच में कोई फ्रिक्शन नहीं है, सो ब्लॉक ए विल नॉट मूव बिकॉज वर्टिकल फोर्सेज आर एक्टिंग देयर ओनली. इसका रोल तो सिर्फ नॉर्मल रिएक्शन बढ़ाना है यहाँ पे इस समय. ओके, तो क्वेश्चन इज, आपको पता लगाना है v की मिनिमम स्पीड क्या होनी चाहिए. कॉल इट v नॉट. सपोज v नॉट क्या होना चाहिए जिससे ए ब्लॉक टॉपल हो जाए. मतलब मिनिमम स्पीड बतानी है v की जिससे ए ब्लॉक टॉपल हो जाए. टॉपल होने के लिए क्या होना पड़ेगा, बी ब्लॉक को स्लिप होना पड़ेगा, इतनी स्पीड गेन करनी पड़ेगी और फ्रिक्शन इसका अपोज भी करेगा, तो इतना स्लिप हो जाए और रुक जाए फिर 2d डिस्टेंस के बाद. वाई 2d डिस्टेंस? 2d के बाद सेंटर मास ऑफ द अपर ब्लॉक विल बी ऑन दिस लाइन. थोड़ा भी अगर आगे गया इट विल टॉपर. तो मिनिमम स्पीड ऑफ दिस ब्लॉक इतना होना चाहिए कि कोलिजन के बाद वो बी को इतना स्पीड दे सके कि वो 2d स्लिप होके रुक जाए. अगर स्पीड वो v नॉट जिस मोनोम ब्लॉक की है उससे थोड़ी भी ज़्यादा हुई तो इसकी पोजीशन थोड़ी आगे हो जाएगी और इट विल टॉपल। तो अल्टीमेटली क्वेश्चन क्या हुआ, हमें वो स्पीड बतानी है कि टकराने के बाद बी हमारा 2D स्लिप हो जाए और अपर ब्लॉक ए ब्लॉक इन द पोजीशन टू टॉपल। क्लियर? ओके। During the collision, we neglect here role of the friction, because when the ball collides with the B, impulse acts. In the question is given, role of the friction during the collision is neglected. After the collision, when the block B moves, then friction start to act. You can say in this way. Okay. Let us apply conservation of linear momentum between small m, capital M block. Role of friction is not there. Internal impulse is acting there. So in horizontal direction, so small m into V plus 0 movement of the B. After the collision, suppose small m come back, so its momentum will be negative here, mv1. Momentum of the B block 4m into v2, so minus v1 plus 4 v2 equal to v. Now Newton's experimental law for small m block and B block. Velocity of separation, ball comes this side, block goes that side, velocity of separation will be v1 plus v2. Velocity of approach will be v minus 0. This is equal to E is 1 here, elastic collision. So clearly v1 plus v2 equal to v. Solving these two equations, we can find out v2 from here by adding them. You will get 5v2, this is equal to 2v, and v2 equal to 2 divided by 5 into v. Clear? Now by this speed, block B moves this side and stops after covering 2D distance. We can apply here loss of energy or work energy theorem. Let us apply work energy theorem for B block. Change in kinetic energy of the B block 0, final kinetic energy 0 minus initial kinetic energy of B block, half into mass of the B is 4m into V square 2v5 whole square. This is equal to net work done on it. Only friction is doing work on the B block, that is minus mu into normal reaction here. That normal reaction will be equal to 6 mg. That will be 6 mg. Mu into n into d. Displacement is 2d here. So if you simplify it, you will get 2m into 4v square divided by 25 equal to mu into 6 mg into 2d. Simplifying it, you will find velocity v for this condition 2 times raised 3 times. So clearly v square equal to 25 into mu into 3 into g into d divided by 2. So clearly v equal to 5 root of 3 mu g into d divided by 2. It is the minimum speed of the ball required just to topple upper block. Clear? Okay.